What's up, everybody? We're back and we're going to talk about properties of chords today. So a chord, if we remember, is just a segment with two of the endpoints being on the circle. So if I have segment AB and it's being congruent to segment CD, then we can actually say that the two arcs are congruent. So if these are congruent, these two arcs are congruent. Arc AB is congruent to arc CD. And the converse is true. If we have two arcs being congruent to each other, we can say that the chords are equal to each other. So AB is congruent to CD for segments. And our diameter chord theorem is saying if QS, well, QS looks like it's diameter. If it's a perpendicular bisector with a chord, then it's gotta be the diameter. So we can say that QS is the diameter. Converse of that is true as well. If SQ is a diameter and it's a perpendicular bisector, then we can say that, well, it's not really a converse, we can say that these two segments are congruent because remember, perpendicular bisector splits it in half. So TP is congruent to, stupid lead, PR. So our equidistant chord theorem is saying if segment EF is congruent to segment EG, so EF, EG, then the chords AB and CD are said to be equidistant. Equidistant, which means they have the same measure, which means they are also equal. So we can say that those are the same. AB and CD have got to be congruent. And if we have EF as being congruent to AG, we can say that AB is congruent to CD, kind of what we just said. And then if AB is congruent to CD, we can say that these two have to be congruent. FE is congruent to EG. Putting it all together. So FE, EG. So what we can say, if FE is congruent to EG, we can say that AD is congruent to BC. So these two lengths are the same, this is the same as this, and then also we can even take it one step further and say that AF is congruent to FD. FD. So these are the same, and then these are also going to be the same. BG is congruent to GC because it's a perpendicular bisector, it's going to have to split it in half. So let's do a couple problems right here. This shouldn't be too bad. If these two arcs are the same, that means these two lengths have to be the same. So AB has got to be the same as CD, which is just 9. If we want to find the measure of arc RS, if this is 100 and these are the same, these two arcs have got to be the same. So the measure of arc RS is also 100 degrees. Oops, 100 degrees. If I want to find NP, let's kind of look at this. This is a little bit tricky. If this is 80 degrees, we know a circle is 360 degrees. So 360 minus 80 is equal to 280 degrees. So that means 280 degrees has got to be split between these two. And if these two are the same, that means these two are the same. So if I do 280 divided by 2, I get 140 degrees here and 140 degrees here. So the measure of NP is 140 degrees. For number 4, if AB is 16, and if these are the same right here, that means these two have to be the same. So CD is also 16. Alright, for number 5, I have 4x plus 1 and x plus 8. If these are the same, that means we're just going to set 4x plus 1 is equal to x plus 8. Move the x over. Move the 1 over. Oops. We get 3x is equal to 7. Divide, x is just 7/3. So let's try this problem right here. It says, find the measure in each circle K if GE is 24. So this whole thing has got to be 24. So right off the bat, we can say that's 12, that's 12, that's 12, that's 12. The measure of arc HI is 67 degrees. So that means this has got to be 67 degrees. This is 67 degrees. And this is 67 degrees. The radius is 13. So from here to here is 13. And GE is congruent to HJ. So we already kind of did that. So HJ, if we look here, the measure HJ is 24. That's pretty easy. The measure of IJ, let's see, IJ arc is 67 degrees. That's super easy. GE, here to here, this whole arc, we'll do 67 plus 67 is 134 degrees. LE, L to E, well it's 12. MJ, M to J is also 12. And LK, so this is where it gets a little tricky, right here. Notice we have a right angle. A radius, it tells us, is 13. And a radius is from the center to any point of the circle. So if I go right here, this is 13, and I have a special triangle. But that your triples, that's got to be 5. Alright guys, your favorite thing in the whole wide world's coming up. Proofs. Proofs are the best. Alright, we're given circle B. So given, and we have our statements. We got our reasons. So 1, we know circle B, and if you want to, it might just be beneficial for you to actually draw the circle B. It's given. That's easy. And it also says D is the midpoint of arc AC. So D is midpoint of arc AC. So if I'm going to draw, joop, 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 we have point A, point C, and we have the midpoint, so these has got to be the same, that's D. So I'm going to call this angle 1 and angle 2. Because these are the same, it's the midpoint, I can say that arc AD is congruent to arc DC. Arc. And that's based off definition of midpoint. An old classic. And because these are the same, we can say that angle 1 is congruent to angle 2. and these are called central angles. We can say this is because of the chord arc theorem. And our whole goal is to prove that BD is a bisecting angle of arc ABC. Or angle ABC, sorry. So we have enough information to say, we can say that BD bisects angle ABC because we said that these two angles are actually the same. So this is based off definition of angle bisector. Last but not least, just because we're in quarantine doesn't mean we can forget our little box. Alright, these ones are pretty easy. What fractional part of a circle is an arc 36 degrees of 200 degrees? Well, we know that a circle is 360 degrees. So 360 degrees, or 36 degrees over 360 degrees, we have degrees over degrees, those can cancel out. 36 over 360 simplifies to 1/10, and that's it. No units at all. Of 200 degrees, so we have 200 degrees over 360 degrees. Degrees cancel out, these zeros can cancel out, and we really have 20 over 36, which can be 10 over 18, which can simplify again to 5 over 9. Not too bad. Number 14, we want to find the measure of an arc that has 7/12 of its circle. So we're going to be doing the opposite. I have 7 over 12 divided by, or times 360 degrees. And really that's over 1. 7 times 360 divided by 12 gives us 210 degrees. And that is it for this lesson. We'll see you back tomorrow.